Alright, so today what we're going to do is we're going to build a virtual gallery that's made entirely by an artificial intelligence, in this case AttnGAN, which is a generative adversarial network. We can type in a description, nice picture of a boat, and it will generate an image for us. And there it is. And it looks weird, it looks funky, but there it is. So we'll discuss all the different parts that needed to get this thing going. So let's get started. The first thing we need is to have this set up in Runway. And Runway, if you don't know, is an artificial intelligence tool, a tool for creative AI that we're going to use here. And has a bunch of models, pre-trained models, that we can use for AI machine learning applications. And the model that we're looking for here is called AttnGAN, a text-to-image generation algorithm. You can learn more about it. As you can see, it's written in PyTorch, but we don't really have to care about that. All we have to care about is getting this model going and running that. So what we're going to do is we're going to have this model either run locally, which we can do here, or we can host this model and then we can interact it. Right now, we are mostly interested in having this model run locally, but later on we can change its URL and host that. So right now what we're going to do is we're going to make do at the workspace. I already have a couple, but I'm going to make a new workspace here. This is just a generated name. Let's call it AttnGAN. And here we can choose where the input comes from. So here we choose text, and here we can also choose whether we want to run this locally, if we can, and that's only if you have Docker installed, or more likely if you want to have it run remotely, and then we can run that. It's going to start a machine up in the cloud and allow us to generate something through text. So I can type here, cabin in the woods, while that's running, and what it's going to do is it's going to take this input, run that through our machine learning algorithm that has learned from images and captions on how to generate these things, and it's going to generate this image. Is this a cabin in the woods? I don't know, but it's kind of interesting. So this is cool, but basically what we want to do is being able to get that image outside of Runway and into our application. And we can do that because Runway by default allows us to connect it to a network. So it allows us to take in that data and then run that to a server. And that's what we're going to do here. So we're going to build a small web application that's going to take this data in and then generate something new for us. And the cool thing is here, the basis of that code is already available. So we can copy and paste that and start working with that. So to do that, what we're going to need to do is we're going to make a new project in Visual Studio Code. So I'm going to open a new window. Where is it? I have to move things a little bit around. There we go. And now I'm going to open a folder, and this is going to be a new folder that I don't have yet. So I'm going to create a new folder, and let's call it AttnGAN Gallery. I'm going to select that folder, and as you can see, it's completely empty. There's no files in here. There's nothing we can use. And we're going to do a couple of things here. We're going to make a new index.html file. So we can do it here, make a new file, call it index.html. And then if we type an exclamation mark and enter or press tab, then we get a basic skeleton of a document here. So we call it like this. And now we need two dependencies. We needed to make our 3D application running. So the first thing that we need is three.js. Three.js is the thing that runs our application here and that renders our 3D view. The other thing that we need is a plugin in three.js that's called Orbit Controls, and that allows us to control and move our scene around. So to get these files, it's kind of a roundabout way, but the way that I like to do it is go to unpackage.com and then look for the package that I want. So in this case, it's called tree. And that's going to give me the entire application here, just as a file that I can save. Now, I don't want the full version, I want the minified version. So what I can do here is type tree.min.js. That's going to give me the smaller version of this. And now I can save this. Make sure that if your browser doesn't understand this, that the extension is right. I'll show you what happens if it's not. So I'm going to save this here. And then here in my folder, I'm going to make a new subfolder called third party. So these are all the scripts that I need for my project here. So this is the file that I need. And again, I'm going to double check here if this is actually the file that I want. So here, and if it's not, you can rename it and make sure that the JS is at the end. Then the other file that we're going to look for is orbit controls. You know that we can find this on GitHub. And the one that we're looking for is the one that is in three.js by itself. So can we find it here? I hope we can. Otherwise, what we can do is we can look for three.js on GitHub like this. And then in this folder, hit T, and that allows us to browse all the files. And now we can look for orbit controls. And as you can see, there's two of them. This is the old one. This is actually the one we want, and then this is the module version. Now we're avoiding modules right now. And as you can see, it says, well, we really want you to use modules. That's fine. We're not going to. So we'll just take this file. And to take that file, we're going to press raw. And again, save that file here into our third-party folder. There's no minified version. We just take this one. So now going back to our project, we see that we have two third-party files, which is the orbit controls and the three.min.js, and then we have the index file. So first we are going to link up these files, TypeScript source, that gives us this thing, and then we can look for three.min, and then we do it again, so the TypeScript source. Again, these are some Emmet abbreviations that we can use. Orbit controls. Make sure that that's completed. And then our actual file, to do that, what we're going to do is make a new file. And in VS Code, we can also immediately, if we want to put it in a subfolder, use js/ and then type the name of our file. So in this case, it's index.js. Cool. So this is empty, but what we're going to do index is just type something to make sure that we can actually see this going on. So we can link that up. And as you can see, this auto-completes here, and that's because I have this extension which is called Path Intelligence. You can install extensions here. I have another extension that I will use in a second here, which is called Live Server, and this allows me to run a live reloading server so that whenever I type something, I can actually see it immediately. And I'm going to try that now. So I'm going to go to View, Command Palette, Control-Shift-P, and then type Live Server, open with Live Server. You see there's a bunch of shortcuts here. I don't actually know any of these shortcuts, so. And I get this. So I can see that the title is correct, that's fine. And then if I inspect and go to the console, you see that I have a bunch of stuff here. And here it says hello from index, live reload enabled, that's the live server. And then we get this warning from Orbit Controls saying that the plugin is deprecated. We know we don't want to be constantly reminded. So what we're going to do in here in Orbit Controls is go to that first line and then comment that out so we never see it again. It's kind of evil, but it works. And now to get the basic of our scene set up, what we're going to do is look at the tutorial, because I always use the tutorial to make sure that I get this. I never know this by heart. So the first thing that we need to do is add a little bit of styling. What we want to do for our scene here is to have it full screen and then have this little input field here at the bottom. So to make that sure that it's full screen, we're going to put our style, our body here with a couple of lines. So let's do that first. So go back to Visual Studio Code, add a little bit of CSS styling, and we're just going to do this in line because there's not much styling going on here. We're going to say that the HTML and the body have a height of 100%. The overflow is hidden, which means that if we go outside of this bounds, we don't see any scroll bars. We don't get a margin here, margin is 0. Cool. We will add some styling later for the input field, but we don't have that yet, so we'll do that later. And then the second thing that we need to do is to get all this JavaScript going. So let's go to our index.js and then actually do this. So get rid of our console log. We know that that works. And basically what we're going to do is copy all of this and then change all the vars to consts, because that's the modern way. We'll add this basic cube just to make sure that it's working. And our basic animation loop. It's rotating the cube, which is nice. We can do that if we want, but we're not going to because we don't care. So cool. So this is our cube. As you can see, we don't have any control over it. We can't click it. We can't rotate it. So that's next. And the way that we do that is using this documentation for orbit controls, which is this. And what we have to do is, after we set up the renderer, is set up these orbit controls. And then in the controls, in the animate loop here, so we're also going to update the controls. And that allows us in the controls to do this. And this enables damping, which means that there's this nice animation going on. Okay, let's see if that works. No, because we don't know what orbit controls are. And that's because we have to write three.orbit controls. Cool, and now we can rotate this around, and as you can see, it sort of nicely animates smoothly a little bit, which is what we want. So we're not that far off from this view, because the way that this is set up is we actually start with this box. Only the way that we use the box is, we're not going to use the box as is, but we're going to make it a bit smaller. So imagine that all the sizes that we specify here are in meters. So we want these big canvases that are about 5 meters high, 5 meters wide, 5 meters high, and 0.2 meters thick. So these are our canvases basically. So this is what it looks like. This is one canvas, and it's square because from Runway, all our elements are square as well. Cool. And so what we want to do is basically put a image that we have on top of that. And what we can do just to try it out is we can take this image, save it, give it a name, and then make an image folder here. That's just a test image, right? And that's going to be like, let's call this AttnGAN test image. Save. And that allows us to put that image on this texture. Cool. So let's try that out. Let's go back to Visual Studio Code. And to do that, we need a texture loader. So we need a way to load our texture here. So we're going to make a texture loader. And again, I don't know all of these things by heart. What I do is I look this up. And then here it says loader.load, and then that's going to set our material. So basically we do the same thing, but we do it in 2 lines. So this line goes first. That's our loader because we are going to reuse that. And then we're going to say load that texture, and then assign that here. So texture is texture loader.load. It's in the IMG folder. I don't know what the name is, so I'm going to copy that name. And then here for our material, what we're going to do is we're going to set the map to the texture. So that's the texture mapping basically. And it's all green. And the reason why it's green is because it uses this color as a base color. So if we don't want that, we can make this white, and now we get this nice image here. Now, we don't get any shading because the material here, the basic material, doesn't use any lights or anything. But the moment we do use a material that uses lights, like Lambert for example, everything becomes black. And that's because we don't have any lights in the scene. So now's a good time to set up some lights in the scene to make sure that we can actually see something. And lights are always a bit tricky, but we're going to keep it simple. We're going to start with an ambient light, so that's just a soft light that just illuminates everything a little bit. So that's called ambient light. And that takes a color. So if you go back here there's a bunch of stuff with lights. You see it just takes a color here. This is a bit too much. And then we just add that to the scene. And that gives us a little bit of light, as you can see, not too much. Because the most of the color comes from another light that we want to specify, which is a hemi light. And a hemi light, or hemispheric light, hemisphere light, this is something that comes from the top here. So we're going to add that here. That gives us a nice little glow here. And then the last light that we want to do is we're going to set a point light. So again, we're going to rename these things. And a point light is going to be right in the middle of our scene. Again, looking back at the documentation, for point light, what it takes here is the color, as you can see here. Then it takes the intensity, so how strong is the light, and then the distance, so what's called the fall off. How far does the light go? In this case, 100 meters, let's say. And then we add it to the scene as well. Now, because our object is right under that light, it doesn't actually show, so we probably want to move that light a little bit around. So now it's at the top, and as you can see, there's a bunch of color there. If we put it here, it's in the front. It's the light in the front, and as you can see, the back is a bit less light. Cool. In a minute we want to set this back to 0 because what we want to do here is a bit different, but let's imagine that works. As you saw here, we have some other things. We have a ground plane, and we have this grid here, so we're going to add those as well. And that's really useful because that gives us some context, some base, some grounding basically. So we're going to add the ground plane here. And the ground plane is a plane, and we want this to be 100 by 100 meters, and we have to be a bit wider for the grid to make sense. And you'll see in a minute what I mean. And it has a material, Lambert, and yeah, here in the example originally said double-sided, but we don't actually care about that. And we're going to set that to a color. And in three.js it's really nice, we can set HSL colors. So 0.1, 1, 0.75. And then add that to the scene. Oh wait, what do we add to the scene? Oh, the mesh. We don't have a mesh yet. So the mesh is the combination of the material and the geometry. Save. Cool. And where is it? It's here. So it's not really doing what we want. It's not really ground as well. It's just facing the wrong way. So we have to change the rotation here. So ground rotation x equals minus pi divided by 2. I don't know these by hand. Again, I tried this out. And as you can see, we do get the ground, but the image is sort of in the middle here. That's because the ground is at 0, 0, so the middle point here, but this box is also at 0, 0. And there's two things we can do. So as you can see, it sticks out. And this is also why we do why we might do the double-sided. If we now set it to double side, you can see that we have a top side and a bottom side. Now, we don't really care about that bottom side. What we do care about is getting these boxes on the right position. So instead of moving the ground, because it's at 0, 0, where I actually want it to be, what I'm going to do is move the cube. And what I'm going to do for the cube is I'm going to use the Y position, so the height. I'm going to set that to minus 2.5, so half of the size of the cube. Whoa, okay, plus 2.5. So I put it right below the ground there, as you can see. Right, cool. So this is where I want it to be. And then also, because our, as I said before, our ground is going to have a little bit of something else. Not too happy with the color though. So I think it's because the hemispheric light that I use a very different color set. So let's see if I can change that. So I'm going to leave these colors here, but what I'm going to do is set some colors here. So the ground color is going to be a bit different. As you can see, it's darkish gray, and then the top color sorry, this is the ground color. Okay, so it's a bit more, it's a bit darker now. And now we can use our grid as well. So our grid takes how big the grid is going to be and how many subdivisions it has. Again, these are all documented. As you can see here, so the size and the divisions. And then, as before, we add that. Whoop, and now we get our grid here. And as you can see, it's kind of flickery. So we have a couple of settings that we can make to the renderer here that are not enabled by default, but are very useful for us to do. One is that we want to set anti-alias to true, and that's going to solve most of our problems here, so that looks much better. And then also we're going to say that if we have a discrete graphics card, a faster graphics card on some MacBooks, for example, we want to use that one. So that it's going to give us a bit more performance, but yeah, less battery life. And then if you have a Retina screen or 4K screen, you also want to set the device pixel ratio, and that's going to allow you to work better on high density screens, also like phones, for example. Cool. In this case, it's just exactly the same. And then another thing that you should always do is set the output encoding to sRGB. Note that that makes the colors completely different, so it's going to change the colors quite dramatically here. In this case, actually, maybe a bit too much. I like this a bit better, even though we probably have to do a bit of tweaking with the image itself. Anyway, so this is a really good start. Now what we want to do is we basically want to get a bunch of these images here. And to do that, we're going to extract out this part where we add an image into its own component. We'll call it add_box. And that takes in an image URL. And what it's going to do is it's going to load that image URL. I'm going to copy this out for later. Make that box geometry, make the material, and then add it to the scene. Now, of course, if we do it this way, all the boxes will be at the same position, which is this position. So we probably want to do something else. But first, let's see if this works. So if I do add box with our URL, it should still do the same, right? So it should still work, right? And it does. Another thing that I want to do now is to move the camera here a bit up. The orbit controls. So I'm going to imagine I'm 2 meters high, and that gives me a bit more room here. So we're adding a box here, cool. But now if we add a second box, that those two are going to overlap. And to avoid that, what we're going to do is make sure that this position is random. And there's a bunch of ways that we can do this. We can just specify random X and Y position. But as you can see here, what I did is basically make a circle of all the images going around. And the way that I use this is using spherical coordinates. So you can use spherical coordinates here to specify any coordinate starting from the 0, 0 point and then going out with a certain radius and a certain angle and then a certain height. So that's what we can specify here using spherical coordinates. It sounds complicated, but it's actually pretty easy if you think about it, as a person standing in a circle and saying, okay, go that many steps in that direction. That's basically what we're doing. So here, instead of setting a position like this, we can say cube position set. We have to look at the vector, which is position is this vector here. This one, set from spherical chords. Set from spherical chords. So it takes a radius. It's going to be a random value, but let's say it's 20 right now. It's going to take a phi, and phi is the random angle, so which direction are we facing. Set that to 0. And then it's going to take a theta, which is the height. So this is going to be 2.5, just as this one's 2.5. So we remove this one. We move that one in. It's not working like that yet. That would be cool, but and it's gone. Oh, there it is. As you can see, we still have a bit of work to do here. What did we do wrong? I'm actually not using this one. I'm using set from cylindrical chords. Sorry, cylindrical chords. Sorry. So it's actually not this one. It's actually moving from this cylinder here, which is this one. So spherical is a bit different. It moves on a sphere, and this is the cylinder. So basically, this round object around this circle here. But these ones need to be random. So how do we make them? Well, we're going to write a random function here. And our random function is going to take a minimum and maximum value. And it's going to use the built-in random function of JavaScript to use this function. So JavaScript has a random function, and that generates values between 0 and 1. To make that into values between a minimum and a maximum, what we want to do is basically find out the range of these numbers. So that's basically the maximum value minus the minimum value. So if we generate values between, let's say, 50 and 100, we have a range of 50. So 100 minus 50, so max minus min. And we take our random value and we multiply it by that range. And now we get our values, but they're not correct yet because we still have to add our minimum value. So they have to start from our minimum value. So do min plus mat random multiplied by max minus min, so our range, and we'll return that. And this is our random value. And that generates random values for us. So our position is going to be random, our angle is going to be random. Let's start with the angle. So full angle goes from 0 to 360. And 360 is actually in radians, so mat pi multiplied by 2. So I do minus that and plus that. Cool, and now we can do a bunch of these. So let's do that in a loop here. For 0 is smaller than 100. Whoa. Cool. So they're all in loop, that's cool. Airplane flying over. But as you can see, they're all facing the same direction, which makes sense, but it's not really what you want. Now, this is easy to fix. There's always a look at function. Normally you use that for the camera, but we can also use it for any objects. So we can say look at 0. We basically look back at ourselves. So we are at 0, 0, 0, except that we're 2 meters high. So we look at 0, 2, 0, like that. And now all of these are facing us, which is super nice. We probably also want to do a bit of random here, just to spread them out. And I see some of them are farther away and some of them are closer. Cool. So this is about everything that we need to do to set up our basic scene from the side of three.js. There's one more thing, of course, and that is to integrate it with Runway. And that is to use this API here. So that's what we're going to do. So the way that that works is if we fetch this, what we get back is we get back an image URL in base 64. We don't really have to know what that is, but we can use it instead of the actual file name that we have. So let's try that out. So I'm going to just copy and paste all of this code, go back to our gallery, and make a function here, because I know that we're going to need it later. And we're going to name that function generate image. And generate image is going to take a caption. So that's the text that we want to search for. And now we just paste everything in. So we fetch that image, we get the inputs, we get the result, and now we do something with the result. And this something is the thing that we have to do. And this is the thing that I set up for. So our result, and let's log that out. So now, if we actually run this function, because we haven't run that function yet, so imagine that we're going to generate this image with the caption "a boat on the river." We can run that. Does this actually work? And as you can see, it's doing a query here, but nothing's going on. Oh, because it stopped apparently. So we're going to run that again. Apparently the server stopped. I have another server running that I probably want to launch that's on a different port, but this one will work for us. So we have to make sure that this thing is running, otherwise it doesn't work. There's also a local version that you can run. Actually, let's try that out first. It's going to do exactly the same thing. It feels a bit like switching out the cake, but that's what we're going to do. So we've now run this, and as you can see, this is what we get back. It says data image / JPEG base 64 blah blah blah. But this URL we can actually use for our make image thing here, or addbox function. So we call this addbox function with the image. So this result is now actually an image URL. So let's comment this out. Let's remove that line. And now let's not make these boxes in the beginning. Also, let's change the camera here. Ooh, nothing's going on. I don't like that. What do we do? Do we get an image? Yes. Maybe it's kind of empty. The boat. So if the image is black, as you can see here, it means that we don't get an output back. There's a bunch of reasons why that could happen, but let's switch back to a remote version. So this is the local version. This is the remote version. This is actually the one we want. It's still not working though. So let's log out the results. It looks like oh, cool. So it's a string here, and that's not actually what we want. And that's because we didn't actually use the caption here. So here we actually should use caption like this. Cool, that's much better. So now we get a longer image. Cool, and now we see the actual boat running, the image of the boat here. Cool. So we made a mistake while copy and pasting that we didn't actually put in the string. We just put the word, literally the word string, without actually showing the caption. So that's not really useful. So what's left is that we want our input field here. So we are going to put in our body, we're going to put a input field. I'm going to cheat a little bit by looking at all the styling that I did. So I'm going to make an input field. The type is text. I'm going to give it an ID so I can access it from JavaScript. And a placeholder, type a caption. And now what I can do is style this. So there's a bunch of things that I want to style for this input field. First, I want it always to be at the same position, so fixed. As you can see, it appears at the top now. It's not really where I want it to go. What I'm going to do is basically use a way to center these things, which is to place it at the place where I want it. And that's going to place the top left corner at that place, and then transform that so the entire thing is in the middle. So now it appears here, which is where I want it. Remove the background. Give it a border. Add some padding. Looks better. Make the font a bit bigger. Make it white. Cool. Now it's super obvious that it's here, so what I'm going to do is change the opacity so it's less visible. But then the moment I hover over it, or I put my mouse inside of it, then I get a focus option, and then here I'm going to set the opacity to 1. So now if I click it, it becomes visible. And I don't want the actual border. And I can animate that transition. So now if I click it, it slowly becomes lightened up. Add a border radius, and I'm done. This is just going crazy a little bit with the styling. Cool. Now that's it. We don't have to do anything there anymore. But now this generate image here, we want to have that happen only when we type in something. So we're going to take our document, search for that caption. Oops, not like this. Caption. And add an event listening. And we're listening for an enter event. So if the key equals enter, now we can actually generate our image. So what are we going to do? We're going to take that caption from the field. So take the value outside of that input field, generate an image with that caption, and put the field's value back to 0. So we don't see anything anymore. And now what should happen is that I can type something here. Cool. To mice. We have to hunt for the image a little bit because they're always they're placed randomly, so we don't actually know where the image is going to appear. And there's a trick that we can do, which is to have our camera focus on that image, and that's what we're going to do here. So we're going to say, well, we're already, the cube is looking at us. Now we want to look at the cube basically, and the way that I do that is at the controls. I can set the target, so I can set the target to where I want to look at. So the target has location. I could copy the location of the cube like this. That works, but I actually want the position of our thing to be sort of in the middle again. So the best way that I found out is to basically make a point that's somewhere in between where we were and where the image is, and place ourselves somewhere in the middle there. So I'm going to make a new point. The position, the look at position, so the position from where we're looking. And I'm going to lerp this and basically make an interpolation between our position, where we were, and the new position. So the look at position by default is 0, 0, 0. So our main position. We actually want it to be 0, 2, 0. So where we are, a bit higher up. And then set the cube position. So lerp, interpolate between our position where we are now and the position of the cube. And then if we to 0.5, it means move in the middle. We want to move a bit closer to the middle still, so we want to use it at 0.3. Again, these are all just experimenting, right? They're not hard knowledge, hard science. But that means that if we save it now, we actually get our cube at the right location here. And the only thing that I'm thinking is a bit weird is I want the camera to start a bit higher up. I'm not sure why that's not working, because I had that before. Oh yeah, I know what we can do. So now we can sort of go everywhere with our camera, and that's cool, but this doesn't really make sense. So in our controls, what we're going to do is we're going to set a minimum maximum angle that we can move our camera. And if we set it like this, we can't actually move the camera up and down. So you see, this has no effect. We want it to have a little bit of effect though. So we want to have like 0.6. That allows us to move down but not up. And then maybe a little bit down, so plus 0.1 or something. So that we can give a little bit of movement here with our camera. And now if we look, if we type something, you see that it rotates to that position. Cool. So that's it. We basically made our visualization, made our weird image gallery here. I made something where we can explore our space with randomly generated AI art. Hope that was useful. Thanks for watching.